Hello subscribers and viewers, welcome to my YouTube channel. In this video, I'm going to show that the sum of the perpendicular legs of a right triangle is also equal to the sum of the diameter circumscribing the right triangle and the diameter of the circle inscribed in the same right triangle. So to formalize the problem, here is the problem statement. This is supposedly in my playlist Vitamath 23, but this is in advance. In any right triangle, show that the sum of the perpendicular legs is the sum of the diameters of the circumscribed and inscribed circles. That is, A plus B equals capital D plus small d. So this is the figure, and from trigonometry, from geometry also, remember that in a right triangle, the hypotenuse is also the diameter of the circumscribing circle. And to review those who are not yet familiar with that, then one proof is the ratio of any side to sine of the angle opposite it is equal to the diameter, or 2r, of the circumscribing circle. That is, the hypotenuse over sine of 90 degrees, sine of 90 is 1, is equal to 2r. Another thing is chords drawn from any point on the circle to the ends of the diameter of the circumscribing circle are perpendicular to each other, or the measure of this inscribed angle is 90 degrees, which is half the measure of the angle subtended by its arc. So this is the arc, which is a semicircle, and that arc occupies 180 degrees. So therefore, that's only half of 180 degrees. So again, the hypotenuse is also the diameter of the circumscribing circle. So the other symbols would be, this leg here is A, and this one is B, and the diameter of the inscribed circle is small letter d, and the radius is small r. So we begin by writing the Pythagoras theorem, which is sum of the squares of the legs is equal to the hypotenuse square, which is in this case the diameter of the circumscribing circle. So that is small a square plus small b square equals capital D square. And we note that this small diameter, the diameter of the inscribed circle, is twice the small radius r. So we then add 2 times AB to both sides of this equation and write it as a square plus 2ab plus b square equals capital D square plus 2ab. We then note that the left side of the equation are composed of terms which are perfect square trinomials, and we define that by the factor a plus b quantity square, and we just write the right side at is capital D square plus 2ab. So we then enforce the area of the right triangle, which is 1/2 base times height, and equate it to radius of the inscribed circle times half the perimeter S. So that is area of triangle equals radius of inscribed circle times half the perimeter S, and I think you're familiar with that. And if you want the derivation of this formula, you also watch the preceding or previous Vitamath problems, which I uploaded in my YouTube channel. So that is 1/2 AB is equal to R, and R is small d over 2, and S is 1/2 of quantity perimeter A plus B plus capital D. We then cancel out 1/2 as shown, then cross multiply, then we have 2AB equals small d quantity, let's group small a and b, then plus capital D. We then distribute the value of the right side. So 2ab is equal to small d times quantity a plus b plus capital times small d times d. So meaning to say this is the value of 2ab from this equation here. And we replace 2ab here by that value. So capital A, so quantity a plus b square equals capital D square plus small d quantity a plus b plus small d times d. Then, by additive inverse, we add negative d times quantity a plus b to both sides of the equation to eliminate this part. So quantity a plus b square minus small d times quantity a plus b equals capital D square plus small d times small d. We then note that the left side of the equation and the right side of the equation has one common term which will make both sides perfect square trinomials, and that is d square over 4. So we add d square over 4 to both sides of the equation, small d square over 4. Then we have on the right side capital D square plus small dd plus d square over 4. The left side is a perfect square trinomial and the right side is also a perfect square trinomial. The left side, the trinomials in the left side is described by the quantity a plus b minus d over 2 square, while the right side is described by quantities capital D plus small d over 2 square. We then extract the square roots. So quantity a plus b minus d over 2 equals capital D plus small d over 2. We then add small d over 2 to both sides of the equation, leaving a plus b in the left side. And in the right side, we have capital D plus d over 2 plus small d over 2. And we then note that small d over 2 plus small d over 2 is simply small d. Finally, we have shown that indeed the sum of the perpendicular legs of a right triangle a plus b is equal to the sum of the diameter circumscribing the right triangle and the diameter that is inscribed in the same right triangle. So that is small a plus b equals capital D plus small d. So that my viewers and my subscribers can participate in the discussion so that you will also learn, I want you to solve this as your part. So this is the problem. The hypotenuse of a right triangle is 17. The diameter of the circle inscribed in this triangle is 6. So what is the perimeter of the triangle? So I want you to solve this, and I hope that you will get the idea from this problem here. And I want you to show that the answer is 40 units. So that's it, and I hope that you enjoyed watching and listening the discussion and you learn new things in geometry, which is very important as an engineering student.